This video shows a metal grinder spinning right next to a heavy, pressurized industrial pipeline. Right now, the technician holding that tool is preparing to cut through the seal, completely blind to what is flowing inside. If that pipe contains flammable solvent and a stray spark from the grinder makes contact with unseen vapors, the ensuing chain reaction will cause an immediate, catastrophic explosion. Industrial facilities cannot rely on blind luck to prevent these accidents. They rely on a highly specific engineered barrier known as the permit to work. A permit to work, or PTW, is a formal, written authorization document. It ensures that highly specific, inherently dangerous tasks are only carried out under strictly defined and controlled conditions. Its primary purpose is to force a pause. Before a single tool is lifted, the system demands that severe hazards, like live electrical currents or toxic oxygen-deficient atmospheres, are accurately identified and neutralized. The document also forces mandatory communication between isolated teams. Maintenance cannot start cutting until production confirms the line is empty. Once signed, the permit becomes a permanent, auditable legal record proving that safety protocols were followed. This structure moves hazardous work from a series of individual decisions to a documented chain of safety, ensuring that every risk is identified and managed through cross-departmental coordination. The PTW system succeeds because it doesn't treat all danger equally. It categorizes every potential hazard into one of 7 distinct profiles, each carrying non-negotiable safety prerequisites. This poster outlines 7 non-negotiable permits. Hot work requires fire watches and extinguishers. Confined spaces demand gas testing and rescue teams. Electrical tasks need absolute energy isolation. Height work requires fall protection. Excavations need shoring. Toxic chemicals demand PPE. Routine cold work requires safe tools. This rigorous categorization ensures that a worker never faces a hazard without the specific defensive strategy required to manage it safely. Identifying the right permit category is only the first step. Before authorization is granted, the hazard must be physically neutralized on the factory floor. Watch how this heavy-duty padlock snaps shut around a mechanical valve. This is energy isolation, often called lockout-tagout. It physically ensures that heavy machinery cannot be accidentally activated by pneumatic, mechanical, or electrical forces while someone is working inside. The safety officer must also verify that specialized PPE is physically present, confirm that the assigned personnel have the correct training credentials, and establish clear emergency communication lines. When a manager finally signs the paper permit, their signature is merely administrative confirmation that all these physical world precautions are firmly locked in place. Let's return to the technician preparing to cut into the pipeline in the solvent area. Under a functioning permit-to-work system, this task plays out very differently. This flowchart maps the process. First, a supervisor raises a hot work permit, and a safety officer checks for flammable vapors. Next, fire extinguishers are staged, a fire watch is assigned, and welding begins. Finally, the area is cleaned, and the permit is closed. The permit-to-work system serves as a life-saving control network, bridging the gap between site planning and the physical work on the floor. Every authorized job prevents an unauthorized disaster by enforcing coordination across departments. Audit your facility's permit systems, upgrade your standard operating procedures, enforce strict safety training, and ensure your control mechanisms are actually protecting your workforce on the floor.